Hello, everyone. I'm Greg DeSell from TechNet. Thank you for joining us as another part of our webinar series. As today, we welcome our partners from Patton Electronics. TechNet is your complete distribution source for the Patton line. We have set aside about 45 minutes for today's presentation and about 15 minutes at the end for a Q&A session. Of course, take note of the Q&A section of your control panel. We welcome your questions, and we're going to do our best to answer them either during the presentation or post-presentation for the Q&A session. And for any we may not get to, we'll follow up and answer those directly post-presentation. Of course, if you're experiencing any technical issues, also drop us a line in the chat. We are proud to usher in the arrival of Dante powered video and audio over IP with the new FPX 6000 from Patton, combined with other products such as a Bolin D220 PTZ camera, and the power of Dante control. The system is now virtually eliminates AV sync problems and alignment issues that have plagued previous integrations of things that we're all familiar with. This among other incredible features. So here to tell us more are Tim Godby and John Grant. Welcome, gentlemen, and thanks for being with us today. Please introduce yourselves and tell us more about this exciting new product from Patton.
We're honored to spend time with you today, and especially all the guests, at least virtually. I'm Tim Godby. I'm the newest member of the product management team at Patton, and it'll be my privilege in just a bit to share with you a follow-up to what Greg's already said about Dante AV and why we are extremely excited about it and what a game-changer device we think it is. But we're going to begin with my colleague John Grant, who's going to tell you a little bit more about Patton. So I am going to share that screen.
All right.
And John, take it away.
All right. So thank you, Greg, and big thanks to TechNet for hosting this webinar today. We're super excited to release this FPX 6000. Thank you to all the attendings also for joining us today. It looks like we got a good crowd today. I can officially say that that Dante AV is not only very real, but it is shipping now. So exciting few weeks for us. This is finally on a roll. I am joined here today with Buddy Oliver, the Executive Vice President of our product line management team, Tim Godby, who introduced himself earlier, and my name is Johnny Grant, and I'm also a product manager here for Patton Electronics. So today's presentation is really all about the FPX 6000. I'll give you a brief introduction to who Patton is. And for those of you who may not know, hopefully we'll enlighten you a bit. We're going to do some quick benefit summary of the FPX 6000, a brief breakdown of the differences between our encoder, FPX 6000T, and decoder, FPX 6000R. What vertical markets we see early on as both ours and your biggest opportunities, and then Tim will take over and give us a good look into a few examples and use cases as time permits, we'll do a question and answer at the end. There's a very good chance that many of you are not all that familiar with Patton Electronics. Our company has been a bit behind the scenes in the audio video marketplace, predominantly with our analog FXS, FXO to IP, voice over IP gateways. We had quite a few installs that we didn't even know were going on in the AV space. Fiberplex, which is now a big part of Patton, has been in the AV market since the debut of the Light Viper brand in 2004. And since then, with a variety of AV over fiber infrastructure products like converters and extenders. Patton has been manufacturing and designing data and telecom equipment for over 35 years. The mass majority of our products are manufactured right here in Gaithersburg, Maryland, USA. We have 5 primary brands. Connect IT, which is really what started Patton Electronics. There's a bunch of legacy serial/industrial copper-based connectivity devices like short-range modems and interface converters. These types of devices are dealing with interfaces such as RS-232, 485, 422, TTL, and even currently. The next brand is their CopperLink brand. That brand is really focused on the copper coax infrastructure based Ethernet extenders. So we allow you to reuse your existing infrastructure for high-speed Ethernet communications. Also included within that brand is a variety of PoE devices such as extenders, boosters, injectors, and splitters. The third is on-site forefront. Really, that's kind of two different brands, but they're really for the same target market. And that is products that are non-voice over IP that are still focused towards the carrier infrastructure products. Those specifically include things like DSL. Smart node, this is everything voice over IP. For example, the product that I mentioned earlier, or analog to IP gateways, fall under this brand. And the big one is FiberPlex. This brand has several different components built in to it. The first is much like Connect IT, but the focus, as opposed to copper, is anything over fiber. And I do mean virtually anything over fiber. Second is a group of managed and unmanaged PoE switches, really focused more on the industrial, towards the industrial market. These are all high temp rated, very strong, sturdy built Ethernet switches. The third is our audio video over IP infrastructure solutions. And this is taking things like 3G SDI, SDI, HDMI, MADI, all over fiber. The fourth component is what we're all here to talk about today. And I'm hoping that this part of the FiberPlex brand really explodes over the next 3 years, and that's going to be the audio video over IP. Briefly about Patton, our historical focus has not been directly in the AV market space, but this is one of our greatest strengths. Working with Audinate, a leader in the AV market, and being able to bring to the table what Patton has learned and practiced over the years in the telco, industrial, and enterprise environments, it's sure to bring in new opportunities and new innovative product offerings. We are proud that Patton is one of the very first manufacturers to bring Dante AV to the market, and even prouder, those products are going to be manufactured right here in the USA. All right, so I'm going to give you a very brief look into what the FPX 6000 features are. I would encourage anybody to go up onto our website. We do have a fairly detailed data sheet up there and some use cases and some other videos. So there's a lot of information coming to our website. But kind of the highlights are, just like the case with Dante Audio, Dante AV utilizes the standard 1 gig network. But now with the video, it's now a complete turnkey solution for both audio and video over IP. Even though we were talking a gigabit network, we can still pass 4K 60, 444 video with very low latency, with a very low latency of 8 milliseconds from HDMI to HDMI. The audio and video are completely time aligned, while at the same time separately routed. Tim is going to show you some instances of this later and how it works in practice. Dante is incredibly unique, and the thing that really made it attractive for us is right out of the gate, it's instantly compatible with over 2,000 Dante-enabled products. So while we may be new to the audio video space, it definitely gives us an ecosystem to be able to grow out. As with other Dante products, you have the unified control. That unified control now includes video. Using the Dante controller, which provides auto discovery, control management of Dante-enabled devices on a network, and soon, the all too familiar Dante domain manager, which allows for user authentication, role-based security, and audit capabilities, as well as expansion to any network infrastructure. That Dante domain manager is in the works. It is not complete. Dante AV uses the popular JPEG 2000 codec, so that's native to the current units shipping. But it's important to note that the Dante AV box, the FPX 6K, is codec agnostic, meaning that any 1 gig video codec can be utilized. It's just a matter of really an engineering project and the opportunity. HDMI licensing and validation, we all know, can be challenging and expensive. The FPX 6K is fully licensed for HDCP 2.2 input and output, and HDCP 2.3 over the network. The FPX 6000 includes a host of peripheral interfaces such as USB 2.0 on the go, or USB on the go, serial. This also includes VISCA and IR. And this is all over IP. And lastly, out of the gate, you have 2 mounting accessories pictured here. On the top of this slide is our VISA mount. On the bottom right-hand corner, it shows our rack mount device that can either hold a single unit or multiple units. Now on to the differences between the FPX 6000T and the FPX 6000R. They are very similar, but there are a couple of minor differences. When you look at the front of the FPX 6000, they're identical. There's no difference between the two. Our FPX 6K encoder, which is the T unit, includes HDMI input and an HDMI loop through circuit for HDMI monitor out. So you can see what you're actually putting into the box. The IR, serial, and USB interfaces and audio are all bidirectional, meaning they can be transmitted into the network or out of the network at either device. That's listed here. That's as IO for both the input and output. Our FPX 6K decoder includes an HDMI output and all the other peripheral interfaces included on the encoder. The only difference is it does not have the loop through HDMI monitor out. Now, there are a variety of markets for audio video over IP. Just a few that come to mind, corporate, education. The amount of inquiries that we've received through our initial marketing, it really shows a strong amount of educational opportunities. House of worship, same. Healthcare, government and military applications. Certainly leisure and hospitality. Utilities, power and energy, that's something that we hope to bring to the table. We have traditionally turned a lot of our telco and our enterprise products into industrial type devices to work in these type of applications, and to an extent, high-end residential applications. So with that, I'm going to go ahead and hand over the presentation to Tim Godby to go over some of the applications and use cases of the FPX 6000.
Thank you very much, John, and thank you again to this huge crowd. It really is a privilege to be able to spend some time with you today and to show you a couple of video examples as well as some use cases that we've collected. There are a lot of these, but we're not going to try to get through all of them today. But if a picture paints 1,000 words, then a video is worth 1,000,000 of them. John had talked a lot about Dante's legendary network clock, and the fact that one of the most exciting things about Dante AV is that video and audio are now perfectly aligned. And we can talk about it all day, but I wanted to show you a little clip of one of Audinate's internal presentations. They're using our gear to do this, but I want you to see what that synchronization looks like. So here we go.
Even with that, I'll be able to show that we can get a signal from HDMI port to HDMI port in about 8 milliseconds. Let me show you how I've got this set up. I have a timecode roll playing out of one device and hitting an HDMI splitter. One output is sent directly to a display, and the other goes to our Dante AV transmitter. The signal is then packaged and sent across the network to our Dante AV receiver, which will then forward the signal to a different display. In the timecode window, the top line is showing you hours, minutes, and seconds going down to the millisecond. The bottom line is just counting frames that go by. Now, I filmed this earlier. The timecode roll is running at 60 frames per second, but I filmed it using my phone at 240 frames per second. Now, before I show you the footage, let's talk about the implications. Obviously, the transmitter is running at 60 frames per second. We can do the math and find one frame is 16 2/3 milliseconds per frame. Since the receivers will be about 8 milliseconds behind, they'll line up like this. We also need to realize that the screens need time to refresh their image. So as we watch the slow motion playback, we'll see the transmitter refreshing its image. Then we'll see the transmitter on its new screen. Then we'll see the receivers updating their image, and then we'll see agreement on the transmitters and receivers together. Then it goes back to the beginning and starts all over again. So I'm playing the footage here in slow motion, but eventually you just want to be able to pause it. Here we can see the transmitter's screen updating. On the next frame, we'll see the image complete. If we go to the next frame, we see the screens for the receivers are updating their image. And if I go one more frame again, we see all monitors are showing the same image. Now we can go through this whole process again. The transmitter is updating, then the transmitter is complete, then the receiver screens are updating, and the receiver screens are complete. The other thing to notice is the incredible lock between the receivers. They update in perfect time with each other. That makes Dante AV a great solution for multi-image displays. Whether you need a video wall comprised of multiple displays, or if you have a blended projection with multiple images feathered together. Now with this combination of tight synchronization and low latency performance, we have an excellent solution for live performance spaces and filming sets.
Excellent indeed. I was going to say, if you could just see this, you have in a video, but when you see it in person, well, it really excites me. So I'm hoping that also it is an exciting thing for you to be able to offer for your customers and clients as a solution in many cases. So again, there's just a few of them we want to go over today. The first I'm going to start with is what we're calling a small house of worship. Not small as in insignificant, just not as many pieces of gear. But on this slide and every other application, we believe Dante and Dante AV truly does enable the best in class audio, high definition video, PTZ control, and KVM functionality, all on that same IP network using Patton's FPX 6000 encoders and 6000 decoders. And this particular drawing, starting at the control position, was at the bottom left of the screen. We have an FPX 6000T, which has a PTZ controller connected to that RJ45 serial port, and a video player for playback of up to 4K, 60p, 444, HDCP encrypted video. That's a mouthful, but it's all true. And up to 8 channels of audio connected to that HDMI input. The encoder presents all of these individual signals, which Dante calls essences, onto a 1 gigabit a second IP network infrastructure. And in this case, it's built on and powered by Patton's managed PoE++ switches. Now the audio, video, and control is now available for independent routing on the network. Using Dante's controller software to manage the routing, those signals can now be received by any one of the 3 FPX 6000Rs in this diagram, or the other FPX 6000T. John mentioned earlier that the devices are input and output. Looking to the upper right, there's one FPX 6000R outputting HDMI to the projector in the main worship center, and then below that, in the lobby area, there are 2 other FPX 6000Rs outputting HDMI to 2 separate screens. Now, the only audio output in the lobby in this case is from the speakers built into the display. But because they have speakers, any of those 8 Dante audio inputs can be sent to those displays, routing through that HDMI output. The other signal from the control area back to the bottom is that PTZ control. That can be, as John mentioned earlier, that's RS422 or Visca, and it can be independently routed to the FPX 6000T that's connected to the PTZ camera within the congregation. So that camera is now being controlled over the network by a PTZ controller, while at the same time sending a video stream from the congregation back to the network, which can be routed again to any of the FPX 6000 Rs on the network. So because Dante AV supports unicast and multicast, I'm going to show you an example of multicast in a bit. The individual inputs of audio and video anywhere on the network can be routed to any individual audio or video output on the network. And this all happens in perfect synchronization with every endpoint device. Audio and video all sharing the same network clock. It's a key feature for Dante Audio, always has been, and now Dante Audio and Video. The next one is a corporate meeting space. And I think we've gotten a lot of interest from corporations. John's also right, education is a huge, huge interest for us, but we think this is also a fantastic use case for Dante AV. So let's begin in the upper left. You have a computer running presentation software. That could be Teams, Zoom, PowerPoint, what have you, as a host controller. And it can be used to ingest video and audio from an FPX 6000R. And that would allow any of the audio and video sources on the network to be received by that computer, as well as any other primary audio or video source. So that could be a USB camera, a broadcast camera, and microphone. Then, in order to output the video, we're still in the upper left, the video and audio collaboration from that host computer, the HDMI output can be connected to the HDMI input of an FPX 6000T. And then lastly, both the FPX 6000 transmitter and the FPX 6000 receiver will be connected to the network via a network switch. So track over to the upper middle, and we've included a bring your own device PC because it's really common in this scenario. And in this case, that wireless dongle is connecting the PC to a wireless sharing transceiver, and that is connected to the network via an FPX 6000T, and from the network, to the network via an FPX 6000T. Also, we have an FPX 6000R heading back wirelessly. Now that may be a little bit of overkill, as the guest PC would mostly just need to send video and audio, but we wanted you to be thinking about what is possible. So staying in the meeting room, but moving across to the right, we have another PTZ camera, just like in the small house of worship. That PTZ camera also requires PTZ control from the network and the ability to send video to the network. And the FPX 6000T in this case will provide both. So it simultaneously can control the camera and ingest the video from it, sending it over the network. So the primary room display right around that same area will receive video from the network, and that source will be determined by the routing matrix in Dante controller. That same matrix will allow you to route the audio and the video independently, and they can be sent anywhere on the network, and again, in perfect synchronization, audio and video, thanks to the fact that the audio and video share that same Dante network clock. Oh, and don't miss the Dante-enabled loudspeakers up at the upper right and Dante-enabled ceiling microphone. Most of you are probably aware that those things exist, but you're beginning to get an overview of a use case that's truly, truly comprehensive. Now, at this point, let me quickly mention something many of you may have already noticed, and that is the 10 gigabit a second dark red line connecting the 1G switch in the middle of the meeting room area and the 1G switch in the general control area. So the path to success for sending 4K video through 1G switches is, among a few other important things, having a 10 gigabit a second interconnect between those two 1G switches. And finally on this one, and this is huge, y'all, the entire conference room setup can then be easily distributed anywhere in that facility simply by extending a trunk line to any other capable switch on the network. This one is a 2-zone bar. This one's kind of fun to think about for many reasons, but one of them is this. Um, it's not only a complete illustration of what you can do with audio and video routing, but in this case, all of the independent audio and video sources are located remotely in an AV closet or a room. And each of those video tuners or cable boxes in the upper middle can send up to 4K video to the HDMI input of the FPX 6000T, as well as receive infrared signaling from either of those boxes. So the tuners are emitting IR, and the FPX 6000T can receive that infrared, and that enables network remote control capability from the 2 zones of the bar to the AV closet room. Just don't lose the remote. The audio and the video sources are all, again, independently routable. Those are called essences on this network, allowing your client to have a variety of different television channels playing on the multiple displays and the projector while playing audio from either that accompanying video source or one of the independent audio sources. So the end result, complete audio and video independence and capability anywhere on that network. In this case, Zone 1 could have the Super Bowl or the World Cup playing on a projector along with the accompanying audio from that video feed. In Zone 2, the game could also be playing on the displays, but background music is playing from that private dining source up there in the right using a Dante-enabled Bluetooth wall plate. A lot of fun with that one. Higher ed, this is such a great market. A lot of higher education institutions already have Dante, and if they don't, they sure know what it is. But those who already have Dante enabled, Dante AV is closing the rest of that loop. We're very excited about this one. So quickly, let's just kind of step through this. In the upper left, at the lectern, we have a USB camera and a USB microphone, and over to the right, an electronic whiteboard. So a professor in this higher education lecture theater could capture their lecture locally on that PC, and with a USB-C to HDMI adapter, send that audio and video to an FPX 6000 transmitter as separate routable essences onto the network. An additional PTZ camera video source is also inserted onto the network from elsewhere in that hall using another FPX 6000T. So quickly, let's look at the bottom of the diagram. You have all of the audio and video sources are sent over the network to that central control room and then output via FPX 6000 Rs. One of those outputs the PTZ camera video. Another outputs the video and audio from the lectern. And notice both of those are interfacing with a video mixer for real-time management. Then the video output from that mixer and the PTZ controller interface with another FPX 1000T, which then transmits those signals independently back onto the network. So that post-mix video feed is output via the remaining FPX 6000 Rs on the network to the learning management system down in the lower left, the monitors at the rear of the lecture hall, and the projector and screen. A lot of fun with that one. Tons and tons of capabilities and opportunities. Just have one more use case to share with you today. There's several more, but this one we're calling large house of worship, but mostly because it is an example of a couple of things. One, a number of video inputs from cameras, broadcast cameras, graphics, PCs, and other video sources, but they're being sent simultaneously to 2 different locations. So let's look at that together for a minute. On the left, you'll see we have broadcast cameras, those graphics, PCs, and another graphics source. The broadcast cameras coming out SDI to an HDMI converter to FPX 6000 transmitters. And notice the video signal as you trace it from left down through that 10 gigabit a second link, and then coming back up. Notice what's going on here. The video signals from the left are being transmitted over the network to 2 locations simultaneously. On the left-hand side, you can see all the displays, the projectors and main level large screens along with balcony monitors and all the other varieties of things you have going on there. And that same video signal is then being transmitted through another set of FPX 6000 Rs, converted to SDI back to a video post-production system down in the lower right. And then one additional one sending an audio and video mix to the live stream. So look at what's going on there. We have video sources sending a signal onto the network. We're taking those signals and placing them in two different locations at the same time. And that is possible because of Dante's multicast. So it is both a unicast and a multicast system. And we believe this type of application is another highlight of where audio and video synchronization is just key because of precision time protocol, being able to synchronize all those endpoints, but also bear in mind, Dante exposes the latency amount. So if you do need to make slight adjustments to get it all perfectly synced up, you can easily do that through Dante controller software. So another example of where we feel in an environment like this one, or anything even close, when delay compensation matters, absolute sub-microsecond video synchronization matters, there really is no competitive alternative that can run on a 1G network. We're very, very excited about it. I have one more video I want to show you because this also has sound, and so you'll be able to see and hear what the synchronization looks like and how it actually works in practice. And then we'll be ready for Q&A, I believe. So here we go.
Here's a simplified diagram showing our small Dante AV system here in the lab. We've got a train set on a tabletop with two Bolin PTZ cameras looking at it. One of these cameras is of course the new Bolin D412 Dante AV PTZ camera, while the other is a standard Bolin PTZ camera with an HDMI output. We've also got the Bolin PTZ controller connected, and it's using VISCA over IP to control the D412. The HDMI camera output is sent to a Dante AV encoder, in this case, a Patton FPX 6000T. And from there, it's connected to our network. The Bolin D412 Dante AV camera is of course directly connected to the network. In each case, an HDMI monitor output is driving the screens on the left side of our displays, while Dante AV decoders from Bolin and Patton are driving the screens on the right side, giving you a side-by-side comparison. We've got a computer to run Dante controller and some speakers if we'd like to make some noise, so let's try it out. We've highlighted some things on our system diagram to show you what we're going to do. We're going to start with the simplest thing, connecting the output of the Bolin D412 Dante AV PTZ camera to the monitor in the upper right. How does one do that on a network? Let's open Dante controller on this computer, then connect our network to show you how it works. As you can see, all Dante devices simply appear due to automatic discovery, and they're now ready to use. There's no need to pre-configure a Dante device to get started. We can open our devices to see all the channels for each one. Note that the transmitter channels are on the top horizontal axis, while the receiver channels are arranged vertically on the left. Icons tell us what each channel is: audio, video, or control. We want to connect the video transmitter channel from the Bolin D412 to the video receive channel of the Bolin D10H decoder, so the video will be sent to the proper monitor. So we click at the intersection of these two channels and voila! We see the video from the camera shown on both the top monitors, the left one connected to the camera via HDMI and the right one through our Dante AV network. I'll add a couple of audio channels as well. It all works the same way. Connecting Dante devices is just this easy every time. Now let's go a bit further. We'd like to connect the Dante AV output of the Bolin D412 to two monitors at once. Do we need a splitter or a matrix switch? No. We simply click at the intersection of the Bolin D412 video transmit channel and the video receive channels of both the Bolin and Patton decoders at once. That's all we have to do. And now both monitors on the right-hand side are showing the content from the Bolin D412 PTZ camera. Adding endpoints in a Dante system is really just this easy. Now, let's add a second video source to our network. In addition to the Dante AV signal going from the Bolin D412 camera to the top right monitor, we're going to take the output from the Dante AV encoder attached to the Bolin HDMI camera and send it to the monitor on the lower right. So we expose the transmit channels for the Patton FPX 6000T encoder and find the intersection of the video transmit channel with the video receive channel for the Patton FPX 6000R decoder. Click, and they are connected. We've now got 2 video streams running independently on our network using standard networking gear and no video splitters or switchers. It's really just this easy to build an AV over IP system using Dante. Thanks for watching.
And with that, we'll turn it over to Q&A.
Thanks, Tim and Johnny. It's really, the power of that is pretty awesome, and the ease of controlling certainly. I'll check here the Q&A panel. One of the questions that I see coming up here in the bar restaurant example that you had, how does the FPX 6000 handle HDCP?
So it is loaded with HDCP keys. So as long as, well, it just handles it. It passes through the network exactly like you would hope it would.
Right, so the unprotected content is no problem, and unprotected content, as long as the sync is authorized and also supports HDCP, so there's that communication with the syncs, and as long as everything's compliant, it'll pass no problem, but it will protect the content in the case that there's a non-compliant sync on there somewhere.
Yeah, I should have added that. Thanks, buddy.
Okay. Don't see any other questions. I would have to assume that you guys did such a fantastic job presenting that.
Of course, that's what it is.
Wait, one is coming in. Okay, here we go. Will this pass ancillary data, closed caption, V-chip information, etc.?
I don't actually know that, buddy.
That's the first time we had that question. Yeah, I mean, I think the certainly could closed caption as part of the video signal, because that's embedded into the video signal.
That's right.
The V-chip information, we'd have to check on that. Actually, I'm not sure off the top of my head. We have to check with engineering to be sure on that. We can get that answer.
Yeah, and the testing lab too. So we'll get a good answer for you.
Okay. Yeah, we can follow up with that customer as well. Next question here says, we have a system in place uses bidirectional microwave links to several sites. Is there any provision to limit throughput to certain locations, or would that be done in the switch?
Well, I mean, it's going to really depend on your, I mean, the signal bandwidth is going to be the signal bandwidth. So if you're trying to put 4K 6444 through that with the compression, you're going to be at 800 meg plus. And that's just what you're going to get if that's what the quality of video you want. If you throttle that in the switch, you're going to end up getting a bottleneck problem. So the real approach is making sure that you're balancing the formats that you're using to make sure if you need a limited bandwidth, you want to start out with the right bandwidth at your endpoints, and so that you're not trying to squeeze something into creating a bottleneck. So it's really going to be depend on your system design and making sure all the way through that you know your bandwidth and that you can calculate that through the system. Ultimately, if you're worried about protection, you got to choose the balance between overuse of bandwidth on your microwave link versus potentially having dropout because you're trying to force too much through it, based on the bandwidth calculation of your source. I don't know if that makes sense.
Seems to make sense, yeah.
Yeah, it's a beautiful answer. And as you reduce your options for video, so 4K P6422 is less bandwidth, and as you go down, it's still a beautiful video signal, just uses far less bandwidth. So but he's absolutely right. It's way better to do it at the source than trying to throttle it through the network devices.
20 megabit pipe is going to be, I'd have to look at the bandwidth calculations for the compression. If you get down into the 10 into the HD spec, you're not going to be able to do any kind of 4K with 20 megs, I don't think. As you get down into HD and SD, formats, you may get it down. But that's a perfect example, right? You know, you got to make sure that the bandwidth you're starting out with is going to be able to fit in that 20 megs, and you want to give yourself a little overhead. So I think that can be done. We'd have to look at our charts. There's some charts available that you can see based on the video format what the bandwidth through the network's going to be. Let me just add one thing on that when we're talking about bandwidth. So while this is a 1 gig network on the standard 1 gig, as long as you're on the switch, that doesn't mean you can go to Office Depot and buy a $30 switch from Office Depot and bring it home and use it. All right, that you're still going to need a non-blocking switch, because like we said, a 4K 6444 signal is going to be north of 800 megs per port. Now that's not a problem, especially when you're using multicast. But if you're going to have multiple devices in the same switch, you need a non-blocking backplane on that switch. And then I think if you might have noticed on some of Tim's diagrams, when you go between switches, that pipe needs to be a 10 gig pipe to extend that non-blocking between switches, right? So if you want all that content, you have 8 sources, say, on one switch, and you're trying to get all that content to another switch, you're going to need the 10 meg connection between switches to another non-blocking switch on the other side. So, you know, there's no magic on bandwidth. It is what it is, and so you just have to, you know, pay attention to what your sources are.
Sure, that makes sense. And hopefully if you're putting in a system like this, you're not getting a an Office Depot type off-the-shelf switch. You're actually investing the time in a you know, a Netgear AV or something that's suitable for this application.
Yeah, and I guess that kind of leads into Kevin's question there about what type of network switch are you utilizing that doesn't have to be a closed network. It does not have to be a closed network. That might be a best practice that you might want to institute, but it's not mandatory. Again, it all comes down to bandwidth. If you're just talking about, you know, getting email and, you know, or whatever on a network and sharing that with some video, that's probably not a problem. If you're talking about massive upload and file transfers at the same time you're trying to have seamless video, you know, it's just kind of going to make common sense. And again, it's knowing what your bandwidth is and just understanding what your sources are and how it's all set up. So all of that can be planned.
And I think in our lab, I know we're using the Patton Industrial, the FP 2008s. Their PoE switch. We've worked with both the managed and the unmanaged Ethernet switches. I know the vast majority of applications that Tim showed are really best practices to use the managed switch, but for simplicity's sake and just for testing purpose, we have used our FP 2008 or FP 1008, our unmanaged PoE switch. And
that works.
And it had good results. I mean, it just depends on how complex the application is.
Yeah, that large church application with all of those inputs and outputs, you're going to need to really pay attention to what infrastructure. On the other hand, a conference room in your corporate facility, you know, maybe it's with a couple of cameras and a monitor or two or something, it's not going to be as critical.
Sure, and I mentioned Netgear because I know they more recently had the M4250 line that they announced back, I think, in the spring, which have really done really well in terms of their design for AV and for larger applications. So those are the kinds of things to be looking toward.
Right. I'm not totally sure I understand Jason's question. Will the user be required to subscribe to hosting sites, or can this be self-contained? And in the case of a live shot, would I need both transmit for the camera from site and receiver for the net return? So the second part of that is, I mean, yeah, there's only one video stream able to be handled per device. And that's for flexibility, for logistical support, for a lot of different reasons. There's only one video stream per device, either a transmit or receive. So yes, if you want bi-directional video at a particular location, and actually we have a 1U mounting rack where you can put 2 units in a 1U and have a transmit and receive. So you would need that. I'm not sure about the subscribing question. I don't know that I understand what that's asking.
Doesn't sound like something that there's nothing that I'm aware that you need to subscribe to.
Yeah, I'm guessing that just for cloud delivery, maybe that's what he's mentioning, but I don't know.
So,
Buddy, since we're getting a whole lot of really great questions about switching and network, we should also mention that the transmitter and receiver, the encoder and decoder, are PoE++. So I believe, is it 60 watts, buddy? I think. Is that right,
Well,
John?
that's typically what defines the PoE, but we really only need like just at 30 watts.
Okay.
As a matter of fact, in the idle state, they're just under 30 watts, but
okay,
we don't want to be on the, but PoE plus is maxing at 30. So we really want to be in a plus so that there's plenty of power.
fantastic. Yeah,
no problem.
it's
that's
just
where-
worth mentioning.
yeah, actually, that's Tim. I'm glad you brought that up. That's one of the points. I think that goes back to the like the Home Depot switch. It's important to use a good quality switch when you're doing these, particularly when you're talking about PoE. I know that we've gotten a few demo switches and thrown them into our lab to try and work that are PoE plus. So expecting to be able to get that be able to do the 30 watt. When connecting, we weren't able to get any of our devices off. When you're using when we're using the FP2008E, the one that's sitting in our lab right now, the managed switch that everything's connected to, that is just a PoE plus switch and it operates fine. That being said, any of the accessories, like if you go to our webpage, any of the accessories that you'll find that we've listed specifically for use with the FP6000. So we've got some PoE media converters, injectors, and splitters. All those are the recommended BT because the price differences between the BT and the AT aren't worth hassling over.
And of course, the units can be powered with a wall adapter as well. They don't have to be PoE.
And that's also on the website.
Now, I do see a specific question about Ubiquiti networking products, which is, that's good stuff. Rather than like dive into each individual brand, I mean, the bottom line is make sure you got a non-blocking switch. And Johnny knows what the other specs, the IGMP snooping and jumbo frames, things that most good quality switches are already going to support. I mean, that's really just what's important, and really almost any decent quality brand switch is probably going to be sufficient.
And I
Although
know
the Patton switches are probably the best ones that you would want to use, just to keep the logos all the same in your rack.
yeah, and that's really we're a 12 port count and under. Anything that you're going certainly in the 24 at least for now. The Netgear switch you recommended is a perfectly fine switch. For Ubiquiti, the only thing I would warn you about Ubiquiti, we've had a couple issues with it, is just make sure that when you're speccing in that Ubiquiti equipment that you're speccing in the non-proprietary Ubiquiti equipment. They do a lot of proprietary 24-volt PoE, and that's something that we would not be able to operate on. So that's just something to kind of pay attention to. They do have a lot of fantastic networking products. They make great wireless access points, but a lot of that stuff is proprietary. I believe it's Ubiquiti and Microtech tend to do a lot of proprietary PoE things.
All right. Don't see any other questions. We can probably wrap it up. And for anybody who does have any further questions, of course, see your Technic sales engineer or reach out to us via chat on our website, of course. I will mention too, the FPX 6000 is scheduled to be at our doors, I believe, late in the month or November at some point. So
we're getting, we are preparing to ship some. So I mean, that's a good point. I'm sure that everybody's wondering about availability. So everybody's reading the news about chip shortages and all those sorts of things. We did plan ahead. We do have some production units going. We have been taking pre-orders since our initial release with Automate. So the majority of what we've already produced is being consumed by pre-orders. And so we have, have obviously another group coming in behind that. And so we will have some supply moving out into 2022 we're in line with everybody else in the industry, and we're just at the mercy of chip suppliers at this point. We are doing everything we can do to maintain supply. Technec did get some stocking supply that they'll be getting, so there will be some there too. But the key is plan ahead, plan way ahead. And that's not just with this product, but really with all of your electronic procurements. You really want to be planning ahead, because all of us manufacturers are in the same boat, and we need as much, if we all work together as an industry, we can get through this chip situation, which hopefully next year will be gone. But planning ahead is key. Planning ahead in your designs is key, and give yourself plenty of lead time. The days of just-in-time delivery where your gear arrives on site the same time your install staff shows up, those days are probably not here right now.
Yeah, you might be a year out before we see that again.
Yeah.
Unfortunately. All right, so I think that wraps it up. Certainly, thank you all for joining us today, and thanks again to Tim Godby, Johnny Grant, and Buddy Oliver at the Patton team side. Technec, like I mentioned, is scheduled to get some of the FPX 6000s, and as Buddy said, plan ahead on that front. See your sales engineers at Technec for any more information you might need. And thank you all for joining us, and enjoy the rest of your day.
Thank you, guys.
Thank you, Greg.
Thank you very much, Greg. Thanks, everybody.
Guys.